In 7.3, Windows of Graphs, we are going to take a minute to focus on that equation that we wrote in the Coral problem. So here's the function y equals 1,200 times 2 to the x, where x is the number of years since the coral was measured and y represents the volume. And we're going to start focusing on making appropriate windows when we graph. As you probably have realized, when you're doing exponentials, you get really big numbers rather quickly, or really tiny numbers rather quickly. And so it becomes important to be able to pick an appropriate um, range, domain and range for your graphs so that you get a good idea of the curve that's happening. So for number 1 on 7.3, we've got 3 graphs here. We've got A, B, and C. And I wanted you to describe how well each graphing window does or does not show the behavior of the function. So that's important. Which of these graphs is showing that exponential curve? We really want to see that show that exponential curve. So if I kind of look at A, we're going from -2 to 4. And our highest y value that we kind of picked over here is 2,000. And I'm not seeing more than just 2 input values. So I'm not even seeing an exponential curve. So this is not a really good representation. If you look at B, we're starting to see the curve, but we've got it scaled so much on the y. What is that? That's comma. That's a million. So is that a million? 1, 2, 3. Yep, that's a million. So we've picked such a high maximum number for y that I can't really tell you what the values are for 0, 1, 2. I can't even tell you what the initial value is to start with. And that's unfortunate because you need the initial value, the y-intercept, to actually write an equation where you're looking at a graph. So when I look at these 3, and let's focus over at C, I really like C the best because I get a nice curve. So I'm going to go with choice C, or graph C, we'll call it. I'm going to go with graph C as the best because I get the curve and I can predict. I can predict values for each input. Remember, an input is the x-axis. I can make a decent prediction on what the volume is at 1 and what the volume might be at 2. I can definitely tell you what the volume is at 3. The volume is at 3, it's around, if this is 20,000, that's half of it, that's 10,000. So I think I would go with C as showing me the best possible window range. Let's look at 2. For each graphing window you think does not show the best behavior of the function, well, describe how you would change it. So for A, I would definitely change, so for choice A, or graph A, I don't know why I keep saying. So for graph A, we need, I can't write today. We need a much higher maximum y value. We need to get our range to go up a lot higher. 2,000 is not nearly enough. Think about it. You're starting at 1,200 and you're doubling. Your first input value after the beginning is already off the chart and you can't even see it. Now for graph B, so I'll do a different color. For graph B, I would definitely scale down the y-axis and make a smaller maximum value. I would scale down the y-axis and lower the max value. We don't need to have our maximum all the way at 1 million because it's going to take a decent amount of years for that exponential graph to reach 1,000,000, and it's not giving us an ability to actually read the volume at year 1, year 2, year 3, year 4. It looks almost like a straight line actually for the first 5 years. Now, if we look at number 3, make the changes you suggested and sketch the revised graph using graphing technology. Now, I really hope we're familiar with Desmos by now, because Desmos will be the best thing for you, because it's so easy to change your window by just zooming in, out, touching on one of the axes, the y-axis, and just scaling that while the x-axis stays the same. So I'm going to go ahead and put this into Desmos and show you guys how to mess around with it. Come over here, and we're going to open up Desmos, start graphing, and I will do it with, let me get it on my computer so I can type better. All right, so y is equal to, we're starting at 1,200, and we're doubling, so your growth factor is 2. If you're going to type this, hit Shift 6, and it brings you up into the exponent. Don't use t, guys. Remember, you can only use x and y. So I'm going to 2 to the x. Now, if you notice on the standard viewing window, you don't see much at all. Remember, your y is starting around 1,200, and the highest for your y is an 8. So if we start to zoom out on both sides, we run into a little bit of an issue. Look how high my x's are, right? I'm not seeing that exponential curve. So I'm going to go back home real quick. And what I want you guys to see is that you can actually just scale the y and keep the x the same. So usually to do it, there you go. See how it's blue now? I'm going to start scaling just the y-axis. Now we're really actually starting to get a nice view, snapshot, I guess you could say, of this curve. And then we can actually come out to the x and expand out the x a little bit. Especially if you know you only wanted to care about maybe a few years before, so around -2. Oh, I always forget that does that. -2, and then maybe you just want to go out to 4, 5, and 6. And then if you still want to keep going, you can still keep scaling. I'm not quite sure how to do it with the mouse, because I always kind of use, this is a touch screen, so I was using my fingers to do it. But if you're going to graph, if you have the Desmos app on your cell phone, I highly recommend graphing on your cell phone, because it's super easy with your fingers to scale the axes on an individual. But get in there, mess around with it, and try and see if you can figure out how to do it with the mouse.